Hello everyone. So in today's class of Physics 1, we started one of the most dynamic topic of physics, that is friction. So guys, what do you mean by term friction? When you just walk on the road or you just drive your car on the road, you just might feel there is a rubbing between the tire of your car and the surface. So friction is nothing, just the resistance offered by the surface that are in the contact when they passed moving each other. Or in other words, we also say that resistance offered by the surface when object is in relative motion with the surface. A question arises here. So what do you mean by the term relative motion? So relative motion means calculation of motion of one body with respect to stationary or moving body. So friction is nothing, just the opposition offered by the surface when two objects are in relative motion, which means the surface of both the objects must be in direct contact with each other. As I already mentioned earlier, that friction is a resistance. So resistance means it always acting in the opposite direction to the force. Let us take in this case the applied force is towards right, while the friction acting on the block is towards left, right? So both are in opposite direction. Friction always acting in opposite direction, right? So if the direction of applied force is towards left, then what will be the direction of friction? It must be right. Okay, acts in opposite direction. So friction is nothing, just the resistance offered by the surface, right? Let's move on to the next topic. It is a type of a contact force. So contact force, which contact means the surface of two objects must be in direct contact like this. Surface of block M is in contact with surface of floor, right? Surface of floor. So friction is a type of a contact force, right? So there are three types of friction. First one is static, second one is limiting, and third one is dynamic or kinetic, right? So firstly we understood static friction, then we move on to limiting, and then we further move on to kinetic. So static friction is the force exerted on the surface by another surface when there is no relative motion between two surfaces, which means in static friction the object is at rest even the friction force applying on it, right? So which means when both the surfaces are in rest or considered to be not in relative motion properly, so the friction acting on the block is called static friction. Like this object of mass is at rest, force is towards right, and the frictional force, which is denoted by small f, is towards left. So the friction, I'm just repeating this statement again, a static force is only exerted a static frictional force is only exerted when there is no relative motion between the objects, which means particle is at rest eventually, right? So by experimentally the frictional force is directly proportional to normal, right? As we already discussed about the concept of free body diagrams in a previous session, so you already know about the concept of normal force, and I'm just repeating as once. Normal force is used to counter the weight exerted by gravity on any object, right? So F directly proportional to N, which means if we increasing the normal force, so gradually the frictional force is also increases. So F equals to mu S N. You already aware about the fact that on cancelling or on removing the directly proportional sign, we get a constant, and the constant here is mu s. So mu s is called coefficient of static friction. So guys, can you tell me the unit of static friction? Unit of coefficient of static friction? It is unitless. because frictional force is also a unit of Newton, while normal is also a unit of Newton. So both are cancelling. Mu s is a number or a scalar quantity, right? Properly a number. Meanwhile, mu s only depends upon the nature of surface in contact. If we can change the surface, so that's why on the contrast, the value of mu s continuously changes. So mu s is only depends upon the nature of the surface in contact. So that's, I hope you're just getting the concept of static friction here. In static friction, force exerted on the surface by another surface when there is no relative motion, which means particle is at rest. Okay. So let's move on to the limiting friction part. Limiting friction is one of the most practical type of friction. So limiting friction is the maximum value of static friction when an object just starts to move. Let us take a practical case here. A car is parked on the road. Okay, so car is at parked, which means car is at rest. So the force acting when car is at rest is called static friction, and coefficient of friction here is mu s. But this car is just start to slide over the surface. Just start. I am just using a word just start. Okay, so the maximum value of static friction that comes into play when body is just at the point of sliding, which means the body just starts to slide over the surface. We called it limiting friction. And guys, limiting friction is also called impending friction. Impending friction. I'm just repeating this concept again. When the object is just start to slide over the another surface, so the value of the maximum value of static friction is called limiting friction. Some practical cases of limiting friction is limiting friction acting the shoes of the person in the floor, which keeps him safe from the slipping. If friction is not present here, or in the absence of friction, the objects will slip down easily. And similarly, the friction force acting between the car tires and road prevent you from skating. The friction, when the car is moving on the road or car just went to some velocity, it's the friction acting between the surface of the road and the tire of the car. So due to which friction, the car is easily movable onto the road without skidding it, right? So limiting friction is nothing, just the maximum value of static friction. Okay, so let's move on to the third part, which is kinetic or dynamic friction. So kinetic friction is here comes into a play when the objects or when the surface are in moving state, or type of friction acting between moving surface, which means our object is continuously moving. A car is continuously moving with some velocity. Let us take any 60 meter per second. Guys, we already discussed the concept of velocity in our kinematics unit. Okay, so when car is continuously moving with some velocity, so the friction acting on the car in this case is dynamic friction. Okay, so mu k here it is denoted by coefficient of kinetic friction. It is also dependent upon the nature of surface in contact. So guys, I hope all of you just getting the concepts of all the three types of friction and the application where all the three different types of friction can be applicable, right? First one is static, second one is limiting, and third one, limiting is also called impending friction, and third one is kinetic and dynamic friction. Okay, so let's move on to the another part. So in this case, all you aware about the free body diagram, FBD, free body diagram. So a block is at rest, so you know the direction of weight acting on the block is towards the center of gravity, which is always downwards, and applied force towards right. So guys, can you just tell me the direction of frictional force on this block? The direction of frictional force towards left, because it's always opposing the direction of applied force, and normal is used to counteract the weight here, right? You all aware that normal is always acting into the opposite direction of the weight. So guys, can you just tell me the forces exerted in x direction or y direction? So in x direction, friction force and the applied force both are in opposite direction. So can we say that friction is equals to applied force? Similarly in y direction, n equals to mg. So in this case, both are the forces in respective direction can cancel each other, and hence the net force acting on the block is zero. So this is the state of equilibrium of body, in which forcing acting on the body, but the net force acting on the body is v0. Similarly, in this case, sigma fx, sigma means summative of forces acting in x direction, and sigma fy means summative of forces acting in y direction. Okay, so guys, can we move on to the next topic, please? Okay, great. So let's move on to the graphical interpretation of friction. This graph is plotted between friction and applied force. So guys, the red portion you just need to visualize here is static friction, which means friction is acting on the body so that object is at rest, while object is just starts to move. So the amount of maximum static friction is called emitting friction, and when object eventually moves to a surface, we called it kinetic friction. Kinetic friction is also known to be dynamic friction. Okay. So firstly, we understood. My question to all of you is, why is it easy to pulling an object than pushing an object? Okay, think about it. This concept is, let's emphasize both the cases, pull or push. Okay, so friction is comes into a play here. Pull and push. A block. So the weight acting on the block is downwards. Great. Normal acting always perpendicular to the surface, which is in upward direction. And we're taking a case of pull here. Firstly pull, and then we move on to the push. So guys, can we say that a applied force is acting used to pulling an object? So theta making with horizontal. So in vector solving, we understood that the angle, the side or the component which forms with the theta is called f cos theta, while the remaining part we called it f sin theta, right? I hope you easily remember the concept of, or recalling the concepts of components of vector. Okay. So in this case, can we say that n plus f sin theta equals to mg? Because n and f sin theta both are acting in opposite direction, exactly counteract the direction of weight, right? Weight is equals to mg. So n here is mg minus f sin theta. Yes or no? Okay. So guys, can we say that frictional force equals to mu n? We already discussed. So mu mg minus f sin theta. Friction 1. Can we say that? Perfect. And when we're talking about the term, in a case of pushing an object, so weight is acting downwards, normal acting upwards. So this is a case of a push. So angle forming with horizontal is f cos theta. Great. And this one is f sin theta. Guys, please mention the direction here. F sin theta is acting in the same direction weight is acting here. So can we say that n equals to mg plus f sin theta? So n equals to, yes, n equals to, can we putting this value into f equals to mu n? Yes and no? Great. So from these two values, f1 and f2, guys, which value is greater? Clearly remember from this equation, or visualize this from equation, f2 is greater than f1. So the amount of friction acting in case of pushing is greater than the amount of friction is acting in case of pulling, and that's why pulling an object is much easier than pushing an object. I hope you will easily get this concept here by drawing some free body diagram. Okay, so let's move on to the next topic of friction. A block of mass 5 kg is acting is at rest. Applied force is towards right and friction force is towards left, and the coefficient of static friction here is 0.5. You can easily simply mu equals to F equals to mu n and n equals to mg here, because mg acting downwards and n acting towards the perpendicular towards the plane, right? So 0.5 the value of mu n into my m into my g. We can on taking the value of g on a precise note, you just always taking 10 if in case 10 is mentioned, or you just taking the value 9.8, right? So let's move on to the second topic, inclined plane. Okay, so in this case, calculate frictional force acting on the block. A mass of m is just sliding from the top to the bottom of the surface. F is acting downwards while friction force is towards upward, which means block is slipped down. So friction is always acting to the opposite to the relative motion. So wait, mg is always acting downwards. So this is 90 degrees, this is theta, is 90 minus theta. Similarly, this is theta. So the component which is the component with the horizontal with the theta is called mg cos theta and mg sin theta. So the amount of friction force acting here is mg sin theta. Okay, guys, what do you mean by angle of friction? So angle of friction is nothing. It is defined as an angle between normal reaction and the resultant force. It's called angle of friction. It is also called limiting angle of friction. In this case, normal or r, we also represented normal by r or n also. Okay, so normal is always acting towards the upward, towards the perpendicular to the plane. Okay, and then resultant force is like that. So can we calculate tan theta here? That is f by r, perpendicular by base. So the value of f here is mu n or r, mu r by r. So can we say that mu equals to tan theta, or tan inverse mu equals to theta, right? So guys, thank you for the session. We contain this some type of the friction question based on friction. I hope you just enjoyed these sessions. Thank you so much.